Solar energy is the only energy source that we can rely on to survive in the future. We would like to maximize the utilization of solar energy. So what we have achieved here is colored solar cells. You know, the red stripes, the blue background, they are actually working solar cells. You want this material, semiconductor material, to absorb all the light. And that's why the traditional solar panel, they look black. They probably can only be installed on the rooftop because nobody gonna want to put these black panels on the side of the building or windows. The rooftop area is very limited. However, there are a huge amount of surface area on the side of the building. Not only the exterior, but also the interior of a building. There are ambient light that we can harvest. You want a structure to be able to absorb this light. But also, it's a decorative item.
You can work on the decorator.
What differentiates our work from work in other labs around the world, most of the colored solar cells, they produce color is because the material itself that is used in building the solar cell, they are colored. But the color will be depending on your viewing angle. So depending on whether you look at from the front or the sideway, the color changes. Yeah. For this type of a decorative solar panel, we wanted the color to be independent of your viewing angle. So here we actually borrowed a new concept, yeah, and that has to do with very thin light-absorbing semiconductor on top of a metal, and that produces a special optical effect that allow us to make the solar panels whose color doesn't change. In our solar cell, we actually go one step further. We have two different versions. One is semi-transparent, and it can be made in different colors as well. And the other one is purely a reflective, so you can make it into a picture. You know, for example, we made a nice U of M logo. There is a trade-off between the multifunctionality that the solar cell have versus the highest efficiency one can achieve. The black solar cells absorb the whole spectrum. A colored solar cell, for example, if it absorbs 1/3 of the light, right, and passing the other light, so that means that the solar cell efficiency maximum will be 1/3 of a black solar panel can produce. But on the other hand, by making this multifunctional, I hope that it can expand the scope of applications rather than just the rooftop. In the modern homes, we want a lot of things to be beautiful, but why not make it also multifunctional, right? Not only a decorative item, but it can also produce electric power.
In a quantum computer, we don't have bits of information. We have something called a quantum bit. And a quantum bit also takes on the value of 0 or 1, but it can also take on, and this is a little complicated,